Hi, my name is Taylor Pauley, and this is Exam 1, Part 2 for Stats 210. And I will begin by answering Exhibit 1, Part A. And so what is incorrect about the scientist's claim is that his math is wrong. The heart, when it's calculated, the heart will only beat 60 million times per year instead of 600 million like the scientists claim. And this type of slippery evidence that is present is just simply called a mathematical error. And because the scientist's math is wrong, it skewed his data and led to an incorrect conclusion. And so for Part B, human inference can cause us to have incorrect conclusions based on incorrect evidence. And the scientist is a good example because he came to a conclusion that was based on incorrect evidence. And because of that, his conclusion ended up being incorrect as well. And so for Part C, because of other confounding variables like pre-existing conditions, the amount of exercise, like the type of person, genetic factors, et cetera, it can be shown that fast food and the link to heart disease is not causal, is not a causal relationship. It's just merely associated. So for Exhibit 2, Part A, correlation describes the direction and the strength of a relationship between two variables. This is different from causation because with causation, the independent variable will have a direct effect on the dependent variable, and this can be found through experimentation. A correlation coefficient is the measure of the correlation of two variables. And so here I have my nice little charts. And so let me try to get this in. So this is a negative relationship, and you can tell because of the slope of the graph because it goes from left to right. And the R value, because it's a negative relationship, is going to be -1. This graph in the middle shows no causal or shows no association, and that is why its R value is -0. And as you can see, because all of the little dots are everywhere on the scatter plot. And so this graph is a positive association, and you can tell because it goes from left to right and it goes up. And so because of this, its R value, which is also known as the correlation coefficient, is going to be +1. So because of this, this association would be positive. This one will be negative, and this has no association in its variables. So for Part C, the increase of teacher salary and the amount of alcohol products sold would be an example of two things that are associated but aren't exactly have a causal relationship. And so for Part D, how many days or how many dogs you have and how much you spend on dog food would be an example of a causal relationship, because obviously the more dogs that you have, the more that you're going to spend on dog food because the more dogs you have to feed. And so for Part E, we study this like causation and correlation as a part of slippery evidence because it helps us identify lurking variables that can be in our data. It helps us identify like when things aren't exactly as they seem, or if there's like another underlying cause of our data and stuff like that. And it also helps us make better inferences. When we know when we know more about slippery evidence, we're able to kind of factor that into our inferences when we read and analyze data. So that's all I have for you, and thank you very much.